Right, thank you for that lovely introduction. I'm obviously too excited, so I couldn't even wait for the introduction to finish. So I apologize for that. I want to talk about developer productivity, especially the increasing focus on measuring and improving developer productivity and developer experience. Before we go into that, maybe we do a show of hands of, have you recently heard the words developer productivity and especially the words developer experience? Okay, so quite a few people, maybe 60%, which is good. Always good to know that the talk is going to be relevant to the audience. Let's just see where we are right now as an industry in our thinking about developer productivity. So if you look, if you Google developer productivity, developer experience, you'll come across a bunch of tools and products that are essentially instrumentation and dashboards that pull data from Git, they pull data from Jira and project management tooling, they pull data from CI/CD pipelines, how fast are builds, how many people are pushing PRs, how many commits are being pushed, and they visualize these things in dashboards with the hope that with these measures, people have the right information to take action and improve developer productivity. But that's not all. We also have a bunch of almost competing frameworks or philosophies of how to even define developer productivity and what measures to use. So about a year and a half ago, there was a management consultancy that published a framework that claimed that they could indeed measure individual developer productivity. And then there was a lot of fun rebuttals from people in our industry about, okay, some folks know what I'm talking about, no, maybe you can't, and maybe it's a bad idea. The likes of Dave Farley and Kent Beck, these are folks that wrote continuous delivery and extreme programming. So maybe we'll do a poll before we get to what my opinion is. Raise your hand if you think one should not focus on individual developer productivity. Should not. All right, okay, that's most of you. So that's basically the whole of my talk. I could end here and that'll be a good result. But we have 40 more minutes. So there's a lot of demand for these tooling because essentially there's a lot of cost pressure and companies are worrying about cost and operational efficiency. So there's a demand for these tooling. There's a lot of tools and frameworks out there. So there is adoption that's going to take place. So the question becomes, for our organizations or our projects, what are the developer tools we want, productivity tools we want to adopt? What are the frameworks we want to subscribe to? What are the measures we want to use? Once we have those measures, what do we even do with these measures? So that's what we are going to try to answer. But before we do that, I would like to spend a little bit of time going back in history and how we got here and see if there are like some underlying ideas that we can, that have shaped the way we think about software engineering, performance and productivity that we can hopefully use to guide our future decisions. So we'll go back in time and think about, okay, where have we been before? So very quickly, there's a slew of these developer productivity, many flavors of tools and frameworks to choose from. This is in 2024. And almost all of them adopt or subscribe to what is the SPACE framework that was published by Microsoft researchers in around 2021. It essentially has two major findings amongst many others, which is one, there's no one magic number to measure productivity, and two, you want to have balancing metrics across multiple dimensions when you're thinking about developer productivity. Okay, I can measure output, which is activity here, how many commits or how many is a developer pushing, but I need to also balance that with outcomes and satisfaction and well-being metrics in those other dimensions. SPACE itself is built on top of research done by the DevOps Research and Assessment group. They did, in 2017, publish their 4 key metrics. Please raise your hands if you're familiar with these 4 key metrics. Okay. So as a quick introduction, these 4 key metrics are essentially foundational to measuring software engineering performance or outcomes. These are metrics that were derived from surveys across thousands of companies. They were also published in this really, really good book on page 19 They were published with also ranking across companies of who's elite, who's medium, who's high, who's medium, who's low. That was good and bad because people just got obsessed with whether I'm elite, a medium, or low. So they missed the other 240 pages of this book, which also has some really good material. This research attempt is essentially an attempt to measure the adoption and impact of the DevOps movement. So somewhere around 2007, 2008, people realized there's a catastrophic cadence mismatch between development teams and IT operations and infra teams, because development teams have adopted Agile, so they're going fast and they want to deploy a lot faster than IT ops and infra teams can support. So one of the first known talks for the subject of DevOps was a talk called Agile Infrastructure. And that brings us neatly back to the mother movement in our industry. So this is the first time I'm repeating a talk, so I've learned a few lessons. So last time I told the story of how this manifesto was written and everybody thought I was joking. It's true that 17 wise practitioners actually went up a mountain on a ski trip, and on that ski trip, they wrote this thing. So literally 17 men went up a mountain and came back down with this document. That's a familiar story. But this was essentially a new methodology for them to solve a lot of the common failure patterns of software projects back in 2001. And they had a lot of confidence in these methodologies because they had actually been doing them for a while now. The most well-known of these is extreme programming. People familiar with extreme programming? So somewhere in 1995, Kent Beck and others developed extreme programming. Okay, so let's take a pause here and think about why it's important to go back and see are there any underlying ideas that we can identify across these evolution of ideas that we can hope to use for our future decisions. And this is a question for the audience, but I'll give you a clue, which is these are the popular visualizations for these ideas. So anybody wants to volunteer, what do you see as a common trend here? Yes? Cycles. I heard cycles as well. Feedback loops. Awesome. Oh, wow. Okay, so Ho Chi Minh has scored much higher than Singapore in this quiz. Yes, it is. Like all of these things speak about feedback loops and cycles. And so the question becomes, okay, will my developer productivity initiative help me think in feedback loops and optimize for feedback loops? Feedback loops are also the foundation of systems thinking. So for me, these have all been in part, at least attempts to apply systems thinking to software engineering organizations. Now this is stuff that is sort of well known in the world of software delivery, but let's make a leap to what we have learned from other industries and we leap to manufacturing. In 1990, researchers at MIT published this book called The Lean Production System, The Machine That Changed the World, and the West realized just why they could not compete with Japan in terms of productivity, quality, cost, variety of things, especially in automobiles, especially at Toyota. There's many, many lean principles that have made their way into best practices for software engineering, reducing work in progress, having small batch size, maximizing flow. These are things that you will hear in the software world, but they come from Lean. Lean itself, and of course, Lean in 2003, few of the folks who were part of the founding members of the Agile Alliance also published a book positioning Lean as a way to do Agile. Lean itself is westernized Toyota production system. So in 1950s and 60s, Toyota was struggling. They had no money. Taiichi Ohno and others developed a system to win in actually a very cost-conscious down market. Sort of in at least some parts similar to the environment we are in right now. Toyota production system built on top of and evolved with something called total quality management. And total quality management has many contributors, but none as significant as Edward Deming's. And the rest of the talk here will center around Demings and his teachings. So Demings was, by all accounts, quite a brilliant man. He was a statistician, he was a physicist, and he was a management consultant. He is largely credited with transforming Japanese manufacturing to what it became as world-beating manufacturing, and that was not always the case. There's a story from the 50s or 40s where there was a town in Japan that named themselves USA, and they named themselves USA so that they could print on the back of the little manufacturing they had made in the USA, because made in Japan didn't mean anything. Of course, for Demings, he was the father of the quality movement. For Demings, it's not about quality. Quality is a point of leverage to improve the whole system. When you improve quality, costs go down because you reduce rework, productivity goes up, you can invest more and build more stuff, so it's a virtuous cycle. So he realized that quality you can move the needle on improving the whole system by moving the needle on quality. And he was talking about build quality in the 50s and 60s, and to be fair, only in 2017 with the publication of Accelerate, as an industry, we've come to a consensus that speed and quality are not trade-offs, they move together. Organizations that are very good at speed, like lead time and deployment frequency, are also very good at quality and stability, like mean time to recovery and change failure rate. So we can't think of these things as trade-offs. Right, so this is sort of a mental model of how these ideas have evolved. Of course, this is wrong. We live in a complex world. There is this is a very triggering image for people who like neatness, but this is how ideas actually evolve, right? Many competing ideas, many other contributors, and now we have all this flavor of DevX and dev productivity tools to choose from that adopt some of this, but also have some competing ideas baked in. But then one thing about systems thinking is models don't have to be correct, they just have to be useful. So it's a useful enough model for us to. Okay, so that's a little bit of history. So now to figure out where we should go next for developer experience and productivity initiatives, we'll use essentially Deming's teachings. And towards the later part of his career, he consolidated things that he taught into what he called the system of profound knowledge. It has 4 dimensions, but all of these dimensions must go together, and you'll sort of see how they're interwoven. So we'll cover them one by one. But honestly, we could have the same conversation whether we take the principles of Toyota production system, whether we pick up the principles of lean, or we look at the guidance in the DevOps handbook. The underlying ideas are fairly consistent. So the first one, right in the center, was appreciation for the system. You don't have to look too carefully at this image here. The point that Deming was trying to make was that you have to think about how value is produced in your teams and your organizations. Like, how is code flowing? Who raises the ticket? Where does it go? How does it turn into code? How do we build quality in, right? What happens next? So how does the flow of value work in your organization? And from that, figure out leverage points that improve the whole system instead of worrying about improving individual parts. His point was that the sum is greater, the whole is greater than the sum of its parts. And I've been trying to talk about this for a while and not very successfully, so I've been trying something new, which is trying to sort of talk about this via a computer-based model of a software engineering team. So bear with me, I hope it works. Doing live demos is always risky. Okay. So this will be new to you because it was also new to me, but try to pay attention because there will be a quick quiz where I'll ask somebody in the audience to tell me what we have learned from this. Okay, this is a bit tricky, so. So what you're seeing here is basically a very simplified model of a dev team of 10 developers, these circles, doing delivery work on a project. The project has a certain scope, and these developers are delivering features in that scope. So when you see that the developers are green, it means that they are doing normal delivery, feature delivery work. But if I speed it up a little bit, you see that at a given rate, developers turn red. What that means is they have found some unplanned work, some unknown problem, some bug. Sort of sounds familiar when you're doing software. You can't plan for everything. So when that happens, they go into a red state, which means that the work they're doing will not reflect here into the feature delivery that they have done. They must finish solving the problem in the red state before they can go back in the green state and start delivering features. So the red stuff is unknowns or unplanned work, and it slows the team down. The third thing to know is that every time they run into a problem, they turn red. It'll take some time to solve it, but they will increase their know-how. And when they increase their know-how, the next problem they can solve faster. So that sounds familiar. As you run into problems, you learn more, you solve problems faster. So if I just speed it up a little bit, you see that initially the team goes slow, then it picks up pace because the number of reds lasts lesser and lesser, and the team manages to deliver the work somewhere in like 150 days for 10 developers, and they spend around 300 man days doing unplanned works. So this accounts to about 20% of the time of the project was spent in unplanned work, which is, at least in my experience, a very conservative estimate. Sometimes it can be much worse. And the chart below shows us, okay, early on in the project, there was a lot of churn, a lot of unknowns were discovered. This is the amount of time it took to solve those problems. Later on the project, as the team gained more knowledge, it was much easier to solve those problems, and they had lesser impact. All right, so far so good? All right, okay. So now I'm going to slow this down again. And remember, so I did 150 days with this strategy, and there's one more strategy I can use to try to see if my performance will increase, and that strategy is simply called ask for help. Okay, speed it up. So in this strategy, whenever a developer experiences a problem or they turn red, they say to their team, hey, is anybody free? Can you help me out? If somebody is free, which is there in the green state, they'll walk over to that developer and they will pair a mob on this problem. So what happens is the team will go slower because there are less people in the green state actually writing features. So the number of feature completion is slowed down. But problems get solved faster because 2 people are pairing on them at least. And both these people will increase their know-how. So future problems will get solved even faster. So if I speed this guy up, and it looked like the team is having a bit of a fit. Velocity was slower earlier on, but then the whole project completed in somewhere around 135 days. For those who can't see in the back, you can ask the people in the front that I'm not lying about these numbers. But anyway, it's like a model, so it's just illustrative. And we spent a total of 250 days in unknown state. So we reduced the impact of these unknowns, unplanned work, and problems by the team pairing on problems and asking for help. So what you'll see in this graph is the amount of time spent on these problems was high early on, but dropped off much faster. Okay. Thank you for bearing with this. I know it's sort of new. Usually people use this tool to model how foot traffic will work at a conference venue. So now we had these 2 strategies. The second strategy did better. When I asked for help, I actually saved 15 days on my project. Instead of 150 days, I finished in 135 days. So what is your lesson? Like, does anybody want to volunteer? What was the lesson in the winning strategy? What is the reason for the bump in performance? Sorry? Because of the pairing. Yep. Yeah, exactly. That's it. That's the only thing we changed, so that has to be the reason. So let's have a quick look at this. This is a sort of a simplified view of that thing. You have a work rate, which your productivity, let's just say, is the total velocity of that the team was running with. Number of people doing work makes the team go faster, but every time an unknown shows up, the team will go slower. But every unknown means that the team's knowledge goes up. As the team knowledge goes up, unknowns get solved faster, the team goes faster. What we changed was we added, also pair on problems, which means that initially the velocity is lower because pairing on problem means less people doing feature delivery. But because the know-how increases much faster, this becomes the dominant feedback loop, and productivity increases in the long run. The team moves faster. Now, what is a common intervention that management makes when they try to get a team to move faster? at least in my experience, one of the common intervention is everybody must deliver this much scope. All developers have this velocity target, and all developers must go as fast as you can. I've not said these words myself, but I imagine that's what they sound like. So what happens in this case? Like, if everybody is asked to go as fast as you can, I'm optimizing for the parts. When somebody asks me for help, I'm too busy worrying about my own delivery targets. I may not help this person because I'm optimizing for my individual performance. But if nobody helps anybody, the whole system underperforms by 15 days. And you can attach a dollar value to that. 10 developers' salary into 15 days. So how do we define systems? Like, what's the lesson here? Mostly the lesson here is optimize for the whole, not the parts. And there's a few ways to think about this. These three definitions, but I'll just focus on the last one because the first two are self-explanatory. Last one was Deming's way of talking about how to think about contribution to a system. So X is my performance, Y is the contribution from the system, and X is Y, and Y is my interaction with the system. There's no way to isolate X and Y. There's really no meaningful way to define individual performance in teams when you're worried about the system's outcome. Okay, one more question before we move on. In this case, we asked everybody to work their hardest. Everybody worked their hardest. Everybody delivered software as fast as they could, solved problems as fast as they could. But we still underperformed the strategy of when people asked for help. So whose fault is that? Whose fault is if everybody focuses on their work and works really hard, you still underperform a team that chose to go slower and help each other out? Any guesses? Yeah. So sort of yes, it's really nobody's fault. It's the system's fault. So you can say it's the people who build the system. They need to think about what to do. But the behavior, the performance is not coming from any developer. Everybody is doing their best. The behavior and the results are coming from the system, from the interactions. So just these are few ways where you sort of, when you hear these things, okay, about your developer experience and productivity, am I thinking in systems, am I not? And a few that I'll highlight is, I've often heard this, we can't perform because our developers are not good enough. Or the problem is with that team, they don't let us they don't work well with us. So whenever you find yourself finding the problem in a group of people or specific individuals, you're probably not thinking in systems. And then what can individuals do? Because there's responsibility on individual developers. So Peter Senge had an answer for that, and he said, personal mastery or investing in getting better at your job every day relentlessly is your job as an individual developer to improve the system. So that's what you can do individually. The second dimension of Deming's system was understanding of psychology. Why? IT organizations are complex systems. IT organizations are complex human systems. So a lot of the behavior in the organization is down to understanding the psychology of the people in that system. So Deming had 14 points. These are just 2 points that relate very directly to psychology. Point 8 is about fear and 12 is about motivation. So let's focus on fear first. And his main lesson is eliminate fear. Don't have a culture of fear because fear leads to underperformance of the system. And we'll tie this back to developer experience. Now this sort of gave us a winning strategy or a better strategy. The condition, anybody wants to help me understand what was the precondition that allowed this strategy to win? Like what allowed people to be able to pair on problems? I'll give you another clue. In that model, I just modeled asking for help as a Boolean. If yes, everybody always asks for help, but that's not how teams work, right? Sometimes you have developers stuck on things and they have not asked for help for days and they're stuck on a task. So anybody wants to volunteer why people don't ask for help or what could affect the probability of somebody asking for help?
Fear.
Sorry?
Fear.
Fear, exactly. Oh yeah, okay, the answer's on this. I should not design question papers, but yeah, okay. Yeah, so fear or one aspect of psychological safety. Now, This is sort of important because psychological safety can sometimes get bracketed in the woo-woo. We don't really, it's nice to say, but we are not really doing anything about it because it feels intangible. But you can model systems where you can see a direct effect of that. Safety means a high probability of asking for help, means you save 15 days on your project, means you save some dollar value in your project. It has a tangible impact on the outcomes of a system. And there's enough data now across software engineering and other fields to prove that. So this is a paper out of the MIT School of System Dynamics. The top project missed their deadline by 100%, and the bottom project missed their deadline by around 180%. And the behavior that the researchers found that was responsible was a pathological culture of anybody coming to me with a problem. I scold them and I treat them badly, and I motivate my people by telling them, don't come to me with problems, come to me with solutions. Bad strategy. Okay, so I've been trying to create a really scary image of trying to encourage people to, oh, well, maybe this is interesting. I've been trying to create a fear of fear, I guess. If you imagine your organization as groups of people, how value flows between them is information. And fear blocks information flows. So I joke sometimes that this is also the picture my doctor showed me about trying to discourage me from eating fried chicken, and it's quite effective, so I'm sharing it with you. Okay, about developer productivity and experience measurement tools. In short, there are models, you can measure it. So when you're assessing a tool, make sure that you can measure psychological safety. There's this model, this is just for you to maybe look up later. So now this is also a very risky joke because my name is Ankit Wal, so I had made a joke last time I presented this that I've improved this model and called it a Wallstrom model, which is obviously a joke. But then 2 days later on LinkedIn, somebody posted, I learned about the Wallstrom model and this is what it says. So this is not a real model, but this is just things because sometimes this feels too abstract to me, so things I have seen happen when organizations have pathological or bureaucratic cultures, which is like there was one recent experience where even a tiny firewall rule change in a staging environment required a CIO approval. That's the amount of fear and lack of risk-taking that's happening and sort of shirking of responsibility. So these organizations look like everybody's really, really busy working on Saturdays, Sundays, overtime, but nothing seems to be getting done. About motivation, this is even simpler. Deming's point of view was that the job of management is to enable people to be able to take pride in their work. Essentially, the job of management is, okay, so I'll come to this first, which is there's research out of, again, Microsoft there's a paper called Today Was a Good Day where they asked developers open-ended questions about what is a productive day, and people said that when they're able to create value, be productive on meaningful tasks without wasting time, it's a productive day. So it turns out people actually want to work hard and be productive. So the job of management is not to motivate people, it's not to get in the way of their motivation. It's really easy to prove. Have you ever received a motivational pep talk from your manager? Has it ever worked? Okay, cool. So now if you think about now you're adopting these frameworks to measure developer experience, right? These are dashboards that can see what everybody's doing in Git and Jira and CI/CD. So you have a lot of visibility on individual actions and team actions and all that. So what is your underlying assumption of setting up your developer productivity measuring systems? So this is ex-colleague of mine, Scott Shaw, introduced me to this concept, which is a panopticon, which is a way to design prisons. And the thing about this is that from one central location, you can see all prison cells and see what everybody is doing, which is an excellent design architecture for a prison because the underlying assumption in a prison is that nobody wants to be there and everybody's trying to escape. But is that the same assumption for your software engineering org? Right? So if you're going to go for command and control and try to do a surveillance state, it's going to probably backfire. The alternative is to use that thing to find out where wastes are, connect people with meaning and impact of the work they're doing. Okay, knowledge of variation. This is, in short, Deming's mentor actually created something called a statistical process control, and this is foundational to all the movements that came after it, which is something called a control chart. All you need to know is that there is natural variation in a system, which means that if I'm measuring, say, points delivered per iteration, number of bugs introduced per month, security issues per quarter, it's not going to be a flat line. It's going to go up and down, right? So what do you do with that variation? Like, how do you think? So the quick lesson here is that that variation is part of the system. It's not because on Friday Jeff did something, so something broke. That's true as well, but it's also systemic. So Deming's estimation was that 94% of the variation comes from the system and only 6% comes from like individual or idiosyncratic things, like something like a bad actor infiltrated my organization and did something naughty. So focus your improvements not on fixing individuals and people and special causes, but on common causes. Focus your improvements on fixing the system. So these are some examples. I'll just talk about the first one, which is we do a quarterly or semi-annual deployment. We do it in the middle of the night to minimize impact. And Jeff, again, did a misoperation, and he skipped step 316 or step 718 of the deployment manual. What do you do here? If you fire Jeff, you work with the assumption that it is Jeff's fault. But maybe the problem is with the system of doing a deployment in the middle of the night and only twice a year, so there's no way of having any, no muscle built up, no practice. And then there's like, okay. The other one that we face a lot is like, oh, I need to report my velocity in the governance forum to the senior management. It's gone down this iteration. Everybody panic stations. So this is something that's from one of the projects that I was on, and we sort of did a retroactive analysis of what happened. So what you see in the blue line is the velocity per iteration. So it's below our target of 10. 10 is what we need to complete the thing on time. Okay, so I'm running really short on time, but so I'll be very quick now. What did we do? Because we didn't have this view or appreciation for variation. We did nothing early on when we saw that trend. When that dipped to 4, we overreacted, and we did a bunch of things. And after that, we celebrated because we thought we had done the right interventions to fix the system. When we interviewed developers after the fact, every single developer had a consensus view independently that if we had done absolutely nothing, the green dotted line would be the velocity of the team, right? Like management could have chosen to do nothing, but we overreacted because we didn't appreciate that the system can have variation. And worst, when you have these interventions, you introduce side effects that can actually make performance worse. One of them is I ask people to work overtime and I celebrate it. And once velocity dips again, I'm asking them, then I'm unsatisfied with their performance. There's a very common organizational pattern called dependency on heroics, which sort of is you can see in other addiction behavior too, and one of them is true for me. If my energy levels are low, instead of fixing the root problem of sleeping more, going for walks, I'll just drink a lot of coffee to try to fix that problem. And it doesn't help in the long run. I just need more and more coffee. For organizations, this looks like heroics. Like nothing can get done without somebody working on a Saturday or working overtime or doing something exceptional to unblock themselves, unblock the org. And we made it to the last of the dimensions. The theory of knowledge. How do we know what we know? IT organizations are complex systems. If I have these bells and whistles and knobs of adjusting developer performance and velocity and seeing my graphs go up and down, I can't just spray and pray and turn a bunch of knobs like we did in that project and hope things happen, right? There has to be a scientific or product thinking way of approaching these problems, and Deming's called that the plan, do, study, act. You may have heard about this as the plan, do, check, act cycle. Essentially have a hypothesis, I'm going to do this, this is the impact it's going to have on the system. Then run that experiment, see what happened, and then take your lessons from it. So then improvement processes, instead of looking like on that side over there, they look a little bit like this, where you experiment your way, make things worse, experiment, adjust before you find, for my organization, these are the practices, these are the systems, this is how to organize teams that gives us the maximum effectiveness, developer experience, developer productivity. Bringing that back to this slide. As management, we did a bunch of interventions, and we have no idea which ones worked, right? First, we ignored the trend. There is a clear trend here. When you chart things out like this, you can see trends. Then we panicked, and we did 4 independent things. A few of them were good, a few of them weren't. I don't have the time to discuss which worked and which didn't, but I'll share them, and you guys can take guesses which ones worked. And then when things improved, we had no idea about what worked. We all patted each other on the back, said, job well done, but we actually don't know how to repeat this result, or how much of it is even a good thing. Are we increasing tech debt? Are we measuring developer energy levels and satisfaction well-being? So there has to be a scientific process when you're trying to adjust these things. For fun and homework, these are the interventions we did on that team when we went into panic mode. Now, I won't say which ones are good. We can discuss them at lunch later. But, OK, the last one we spoke about, that's just the thing was going to bounce back anyway. But these are for you to think about. Finally, again, you can't just copy somebody else's model. We'll just do what our competitor is doing for productivity. We'll just move to the Spotify model. You have to experiment your way. Each organization is unique. And just slightly over time, the conclusion. So 4 points, lining to the 4 aspects of Deming's system. Improve the whole system, not just the parts. Your system should avoid fear and surveillance, but be focused on waste elimination. You need to understand and tolerate variation, and then you need to experiment your way to success. All right, OK, thank you very much. I'm sorry there's no time for questions, but I'll be here the whole day.